Okay, this is the back of Thursday's notes. We are graphing absolute values. We will be discussing a bunch of other things, but the focus is on graphing absolute value functions. All right, quiet please. Focus on the lesson please. So there are three parts of this that's going to be numbers. A, H, and K. If A is positive, it's going to be opening upwards. If A is negative, it's opening downwards. Now what does that mean? Up and down. So in the example over here, this is opening upwards. Okay? That's considered opening upwards. So opening downwards will look like that. Right? So opening upwards is like a valley. Opening downwards is like a mountain. All right. And then you have HK. HK is going to be the vertex. The vertex is this corner. So this has a vertex of 0, 0. Okay, the vertex is 0, 0. So let's reconcile this formula and what's written right here. This is y equals absolute value of x. What is the number in front of this absolute value of x? A 1. So remember, whenever there is a space for a coefficient, but there is no coefficient, that coefficient is 1. So the coefficient is 1, or a is equal to 1, making it, it's positive 1, so it's opening upward. And what's being added to x in here? 0 is being added to x, right? So if you have x plus nothing, or just x with no plus 0, plus anything, that means 0 is being added or subtracted, and outside nothing's being added. So the vertex is 0, 0. Okay, so that's how, so I reconcile this expression with this expression, where the h and k are zeros. All right, let's go on. So we're going to look at these functions and determine just two pieces of information. Okay, just two pieces of information. All right, so first, where is the vertex? All you got to do is look inside here. So that's going to be 3. It's always the opposite of the number you see. So that's a -3. So you write positive 3. And then the y value is just that. So that -2 is that's it is. That's what it is, -2. So my vertex is 3, -2. For the direction, you look at the number in the front. This is negative, so that means it is going downwards or opening downwards. So you just write down. Okay, so we say the direction is down. Once you get with the idea of opening up or down, then you'll be okay with it. All right, so don't use the word point down, right? Because this is like pointing down. Do you understand? Do you understand? Because I think you'll get confused if you say it points downward, because this is pointing down, right? But we say it's opening upward. But this is opening upward. All right. So B. So my vertex is going to be the opposite of what you see. So it's plus 8, it's going to be -8. And what's being added on the outside? 0. Added, right? I'm asking what is being added, and that's 0. And the direction is going to be, what is that? Upward, right? It's opening upward. I took the roll incorrectly. Who's missing over there? Cameron.
Cameron was supposed to come back today, but they
They made
made him leave.
him leave? Okay. All right. Moving on. C. Okay. So what's the vertex of this one? 0, 6. Okay. There's nothing being added inside, so that's where the 0 comes from. And then you have a plus 6 outside, so that's where that's a 6. Which direction does it go? Up, right? In front is a positive 1, so it's going up. It's positive, so it's opening upward. And then D, there's a negative sign up front, but what about the vertex? What's the vertex? 0, 0, right? Nothing's being added inside, there's nothing being added outside, so it's 0, 0. And the direction is down.
How is it down?
Because there's a negative sign outside, or you can think of that as being a -1 outside. So A is equal to -1. Yeah?
If we just put 0 on the vertex, would we get 1 off?
Yes. because vertex is an ordered pair. Okay, the vertex is an ordered pair. Unless you wrote origin, then I will take that. But not a simple 0. All right, moving on. Okay. So these examples are a little more sophisticated. All right. But the point is to graph it, though. Okay, the point is to graph it. All right. So vertex. So what's the vertex of this one?
1, -4.
1, -4. Okay. Now, see the term slope? Okay. So we're going to use that term loosely here. Okay. Slope is going to be how tilted this graph is. Okay. How tilted this graph is. And you'll understand it better when I actually do the graphing. So, but I'm just going to tell you the slope is that number in the front. And we're just going to say it's 1/3. Okay. So technically, that's actually not the correct thing to call it. But that's as good as anything else. Okay. So if your future math teacher says, "What? Who told you that?" You can say my name. And they go, "Oh, he just makes up crap." And that's true. Okay. So, but that's because sometimes there's an easier way to describe something. It's an easier way to describe something. All right, the direction. Which direction is this going? So you can look at the slope. It's positive, so we can say the direction is up. Now, for the domain, for all of these problems, the domain is the same. The domain is all real. Okay. Someone asked me today, "Can I just write AR?" No, but you can write the special symbol for real numbers, and that's adequate. Okay? That's the special symbol for real numbers. You have a double line with the R. So if you just wrote that letter, that's okay for me. Okay? That's enough for all real. The range, okay? This is opening upward. This is opening upwards. So we're going to say y is greater than or equal to, because it's opening upward. And you just look at the y value, -4. Now, you might not understand how that's the range, but you'll understand it better after we do the graph, okay? You'll understand the range better after we do the graph. And in fact, the number of solutions, I'm not even going to try to answer until I've done the graph, okay? All right, so we're going to start with the vertex. The vertex is 1, -4. So I'm going to plot a point at 1, -4, which is right there. Right. There's the vertex, 1, -4. Now I'm going to explain what I meant by the slope thing. You're going to go, so remember the slope was 1/3, right? So I'm going to go up 1 and over 3. And I'm going to do that in both directions. Up 1 over 3. All right? And I'm going to do it several times here. Up 1 over 3. So I've done 2 dots this direction, up 1 over 3. Now I'm going to go a couple more dots over here. So it's up 1 over 3.
Is that the answer? That
Up 1 over 3. Huh? Ask again, please.
That line right there that you just made.
The dots I did? So I need to finish that. I want to connect them.
Yeah.
And then that will be the answer, yes. Now, let me ask you this. If this kept going, would it cross the x-axis?
Yes.
If this side kept going, would it cross the x-axis?
Yes.
So it crosses the x-axis twice, and that's the number of solutions. Right? Crossing the x-axis is a solution. Crossing the x-axis is a solution.
That's the x, will it ever be y?
Right. We never talk about the y, intercepting the y-axis as being a solution.
So if that would have been above the x-axis, you would say 0?
Correct. So that's a good point. So I can have 2 solutions. I can have 0 solutions. I can have 1 solution. Can I have more than 2 solutions? No. Okay. So your choices are 0, 1, or 2. Okay. So, and I want you to think about it. Don't just say, "Oh, it doesn't cross it," but it could cross it, right? If it kept going, it'll cross it, and that's what we're talking about. This will cross it on the left side and the right side. Okay. Let's look at the second example. Second example. All right. What is the vertex of the second example? 0, -3. Right. 0, because there's nothing inside the absolute value that's being subtracted from x. And the -3 is the number outside that's being subtracted from absolute value. So what's the slope of this one? -1. That is the coefficient outside of the absolute value. By the way, in this class, I'm not going to put any coefficients inside. So you're not going to have absolute value of 2x in here, okay? I'm not going to do that. Not that you can't, I'm just choosing not to as a teacher. All right, direction. So which direction does this go? Downward. So this is going to open downwards. And the domain is the same, so it's all real numbers. And the range. So this is facing downwards, so when it's down, I say less than or equal to. And it's that y value, so -3. That y value, -3. Okay? Oh, I said earlier that it's easier to understand the range by looking at the graph, and I forgot to mention that earlier. All right, so I'm going to do this one and then talk about it for both of them. Okay? All right, so let's graph this before we tell how many solutions it has. So the vertex is at 0, -3. So 0, -3 is down here. Right? 0, -3 is down there. And it's going downwards, and there's a slope of -1. So it's down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And then it's down 1 over 1 on the other side. Down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Okay, so there's my graph. Huh?
Solution 0.
Oh, thank you. Yes. So this is not going to cross the x-axis. So we say the number of solution is 0. Now let's talk about these domains. Let's talk about these domains. So the first one, I say y is greater than or equal to -4. So the lowest y value is down here. And then after that, it keeps going up. So this one's going up slowly, but it keeps going up. So that's why we say the domain is y is greater than or equal to that -4 value. And then for this one, it's going downwards, so we say the domain is y, I'm sorry, the range. Did I say domain over here? But it's the range, I'm talking about the range. Is y is less than or equal to -3, so it's going downwards from -3. That's why we say the range is y is less than or equal to that y value there. Okay, so the range is what y values are part of this problem. What y values are part of this problem. So it starts at -3 and it goes down. For this one. On the first one we did, it starts at -4 and goes up from there. That's why it's y is greater than or equal to -4. Okay. Final example. All right, final example. All right, so what is the vertex of this one? -2, 0. Remember, for the x part, you're going to take the opposite of what's inside. Right? You're going to take the opposite of what's inside. And what's outside, well here, there's nothing outside, so it's 0. Okay? And the slope, what's the slope of this one? -3. So that's the coefficient outside of the absolute value. And the direction it's going? Downward. And the domain is all real. And the range, what's the range? Y is less than or equal to 0. So it's because it's facing downwards, we're going to use less than or equal to 0. That's the y value here, right? So your range is going to come from your vertex. It's the y value of your vertex. Can you guess how many solutions this one has? Before I graph it?
None.
Okay, I heard every possible guess. I heard 0, I heard 1, I heard 2.
It's on the x-axis, but
It's on the x-axis, therefore
it's more.
it has one solution. Right? The vertex is at -2, 0, so it's here. Right? It's right here, -2, 0. All right, the most common error today was people putting -2, 0 over here. Okay, make sure you pay attention to that ordered pair. Okay? It's always x then y, x comma y. All right, so this has a slope of -3, so I'm going down 3 over 1, down 3 over 1. And do the same on the other side, down 3 over 1, down 3 over 1. There's the graph. Now, the assignment today is basically the graph, okay? But in order to do your graphing, you have to identify the vertex. You don't have to write it down. You can just plot the point. Just be careful plotting the point. So the most common error today was people putting the vertex in the wrong spot, okay? And then you still have to find the slope, right? So that you can draw your vertex. I'm sorry, your absolute value graph. So the biggest part of today is getting that vertex and the slope right. Not so much the other stuff, okay? Or you do need to know which direction it goes, up or down. All right? So what I want you to do is work on this independently, and I'll come help you individually. All right? And I'll
We have
zoom
to do
out so you
11
can...
and 12.
Yes, 11 and 12 is just like what you did last week. Yes.